So welcome back. Hopefully you got the following variances, and now we can start looking for any sort of connection. And we saw the standard deviations didn't really do anything like the means did, but when we look at the variances, what is the relationship between these three numbers? And we have 1.18, 0.89, and 2.07. Well, cool, I do actually see something, and pause the video if you don't see it yet until you notice something. Hopefully you've now noticed that the standard deviations don't add, but the variances do. And this is actually a really cool moment, and I hope you appreciate it. We can now describe that the variances that they do add, the variance, and let me write that with just a shortcut of VAR, variance X plus variance Y equals the variance of X plus Y. If we write this a little bit differently, then we can appreciate a nice way to remember this. The variance of X is just sigma X squared, plus the variance of Y is just sigma Y squared. And if you do that, you get sigma of X plus Y squared. And if you look at this formula, then you can see this is the Pythagorean theorem. And we do actually call this the Pythagorean theorem of statistics. And so that's a pretty awesome deal. Make a big note of that in your notes off to the side, off of this document, the Pythagorean theorem of statistics to combine independent random variables. All right, after you do that, let's check out what happens if we subtract. Once again, you're expected to punch in and find the difference and the number of passengers. Let's skip ahead and see the results down here. And so there's the mean and the standard deviation. It's not filled out, but I'll let you guys pause the video and double check that from the previous page you can get the mean and standard deviation of the difference by doing good old list 1, list 2 for these numbers. Okay, if you've arrived at these numbers, good job. 1.44 is probably the thing that you needed the most time to figure out because standard deviation is not easy without using the graphing calculator. But I went ahead and got the variances as well, and we're looking for patterns again. Hopefully we can see that right here the expected values are doing the same thing, that we could say the expected value of X minus the expected value of Y is the expected value of X minus Y. So no big surprise right there, it's doing the same thing. The standard deviations is still a mess. I mean, we can't add those together, we can't subtract them, it's not really doing anything. But this is what's so cool is that the standard deviations squared are doing the same thing that we did earlier with addition. And so we can write over here that the variances still add. And we can write it as variance of X plus the variance of Y is equal to the variance of X minus Y. Now, this is pretty trippy because you're like, wait a minute, I'm subtracting, but the variances always add. And that's a pretty cool connection that you can say, well, based on the Pythagorean theorem of statistics, I'm squaring the standard deviations and I'm adding them up. An easy way to think about this logically is that when you were combining, remember we're combining Pete and his sister, and we're looking at the difference between them. And if you go back to just examining each one of those independently, you remember that Pete has his own distribution. This is his distribution right up here. And Erin has her own distribution. Her distribution is right here. And if you combine them either with adding or subtracting, that is going to increase the diversity of the responses. And so, yeah, variances are going to add even if I subtract them. So, pretty cool situation. All right, so we're going to put this all together. Down at the bottom, you have a practice set. I'm going to pause the video and you can check your answer at the end. So finishing this up here, one quick note is that 3x and x plus x plus x